Hey there, grade nines. Welcome to today's lesson. This is lesson 2 of chapter 3, and this is adding rational numbers. So when we're talking about adding rational numbers, there's a couple things that we need to kind of review. Okay, number one is what do we do when we're adding decimal or fractions? Sorry. So if we have, for example, 3 over 8, and we're adding 7 over 8. Okay, one thing that we have to make sure that when we're adding fractions is that we have the same denominator. Okay, when we have the same denominator, all we have to worry about is adding our numerators. So in this case, all we're focusing on, or what it ends up becoming, is 3 plus 7 over 8, okay, which ends up giving us 10 over 8. And then that can be reduced, it can be reduced to 5 over 4, or 1 and 1/4. But we don't do anything to the denominator. Okay, that's probably one of the biggest concerns. We do not do anything to the denominator. The other thing that we want to focus on is what happens when we're actually adding integers. Okay, I know it's been a while for some, and because we initially learned it in grade 7, and we've touched on it a little bit kind of over the years. So I'm going to use kind of the same example. So the possible outcomes that we could have are 3 plus 7, negative 3 plus 7, 3 plus negative 7, or negative 3 plus negative 7. Okay, so in my opinion, adding is the easier way to go. So when we have 3 plus 7, that's something you've been working on since grade 1, and we're going to get 10. So here we have positive 7 and negative 3. So when we have different signs and we're adding, what we're actually doing is we're taking the difference between those two numbers and we're keeping the sign of the bigger number. In this situation, 7 is bigger. Okay, how much bigger? Well, it's bigger by 4. So it's essentially becoming 4. Okay, positive 4, because our 7 is bigger than our 3. In this situation, our 7 is bigger and it's a negative. So what's going to happen when we find the difference between them, because we have different signs, a positive and a negative, so we're going to take the difference between them, which is 4, but we keep the sign of our larger number. Okay, 7 is a larger number than 3. And then here we have positive or negative 3 negative 3 plus negative 7. So we're starting with negatives and we're adding more negatives. So we end up with negative 10. All right. So with those things in mind, hopefully those will kind of help you out as a quick refresher on adding fractions and adding integers. All right. Now let's actually move into some examples. And one of the ways that the textbook is going to actually have you try to do this is to use a number line. All right. So I'll give you one example before we kind of get into number lines. So if we're adding, let's say 2 over 3 and 1 over 5. All right, so just as a reminder, we have to find a common denominator. So we need to figure out what denominator we can use for both 3 and 5. Well, if I count by 3s, I get 3, 6, 9, 12, 15. I know that 15 is a multiple of 5, so I'm going to use that. So I'm going to multiply both of these by 5 and both of these by 3. So I end up getting 10 over 15 plus 3 over 15, which is the same as saying 10 plus 3 over 15, and my answer here is 13 over 15. All right. So that's one way to do this one. The number line example that we'll do. Okay. Let's go with negative 5 over 8 plus negative 7 over 2. Okay, let's start with this. So we've got two sets of negatives. Now, I'm going to draw my number line. Okay, so I'm in the negative side. So if I say that my 0 is over here, okay, then I'll have negative 1, negative 2, negative 3. Let's keep going. Negative 4. And we'll stop over there. Now, when I'm looking at my first fraction, I have it broken up into eighths. So that means I have to have 8 sections. Okay, so that's halves, quarters, eighths, halves, quarters, eighths, halves, quarters, eighths, halves, quarters, eighths. Let's say that's half, quarter, and then eighths. There. So I'm starting at negative 5 over 8. So 1, 2, 3, 4, 5. So this is my starting point. So negative 5 over 8. I'm going to use a different color for our hops. Now, what's happening? I'm moving 7 halves. Okay, I'm moving 7 halves. So I'm adding 7 negatives. So I'm moving further in the negatives. How far is a half going to be? Well, a half is going to be 4 of the 8. So I'm going to be moving 1. So this is 1 half, negative. Here again, negative 1 half. Go again, negative 1 half. And again, negative 1 half. So that's 1, 2, 3, 4. I need to go 7 times. So I'm going to keep going. Negative 1 half, that's 5. Negative 1 half, 6. And negative 1 half. So where do I end up? I'm right here. Okay? So what is my answer over here? My answer is negative 4 and 1/8. Okay? That becomes my answer. Negative 4 and 1/8. As I'm making those hops of half. Okay? If I look at it a different way, I could try to find a common denominator. So in this case, my common denominator would be 8. Okay? So I've got negative 5 over 8 plus negative, I need to multiply both of these by 4. Okay, so 7 times 4 is 28 over 8. So now I'm adding these together. Okay? So that gives me negative 33 over 8. If I want to reduce that, I can take 4 wholes out. So 4 times 8 is 32. Subtract 32 from 33, I get 1 over 8. And the whole thing is negative. And that's the exact same thing that I got previously. All right. So the number lines, it is a little bit tricky if you have different denominators. But one thing is you can actually just make sure that you have the proper amount of jumps so that you're not missing spaces. Okay. So what I mean by that is, say if you were to have like thirds and fourths, you would probably want to have 12 ticks. Okay, and then so that you can still make the proper jumps. Similar to what you would basically have as your common denominator. That's how many ticks you would need for each whole number. Okay, I hope that makes sense. Anyways, if you guys have any questions, let me know in the Hangouts, or you can bring your questions to the Zoom chat. All right, good luck.